The Very Large Telescope, or VLT, is one of the most advanced telescopes on Earth, and it sits on a quiet mountaintop in the Atacama Desert in Chile. Whilst conducting a survey of 7,000 dead stars called white dwarfs, it found something unusual and unexpected. Ingo Waldman, a lecturer at University College London working in the field of exoplanets, talks with me about the discovery.
Yes, so what they found is the first detection of a giant planet around a white dwarf star. A white dwarf is what stays behind after a sun-like star goes through its giant phase and its supernova phase. So it's a stellar remnant, right? And so they're very hot.
So what's remarkable is that the planet is still intact. This was previously not thought to be possible due to the destructive energy a star emits during the final stages of aging in a supernova explosion, turning planets within the solar system to rubble. As our sun is also destined to turn into a white dwarf, this finding could offer new insights into the future of our solar system.
Yes, in about 4 billion years' time, our sun will go through its final stages, and then what remains is a white dwarf very similar to this one, actually. And we don't really fully understand whether our solar system will remain intact or whether some planets will and some planets won't. But likely our giant planets will remain. And yes, so this is basically a snapshot of things to come for our solar system.
So how did they make this discovery? The VLT has a special instrument called the X-shooter, which is used to get the chemical breakdown of celestial objects.
What they do is they look at the spectrum of the star in the ultraviolet and X-ray. So basically, they're looking at the chemical fingerprint of the atmosphere of these stars. And if they find anything but the expected hydrogen and helium, they know something's up. And in this case, they found quite a lot of oxygen and a bit of sulfur and nitrogen species, which isn't really expected if it's just a sort of rocky remnant. So it strongly suggests that what's actually accreting onto that star is an atmosphere of a planet.
The loss of atmosphere is due to radiation from the white dwarf heating and boiling off the atmosphere of this Neptune-like planet into space. Using these measurements, they were then able to figure out that the escaping gas is pulled in by the white dwarf's gravity, which then spirals into the white dwarf, forming a disk.
It's the first time we find a giant planet around a white dwarf star. So that's very significant because it confirms what we thought to be the case in terms of planet formation, but we've been proven wrong for so many times when it gets to planet formation and planet formation models. The fact that we can actually see this with direct evidence is very reaffirming.